Welcome to my channel Simple Concepts by DJ. Today, before getting into the integration, I found that one problem is there in differentiation, which was considered to be one of the most important problem as far as NCERT 12th standard syllabus is concerned in differentiation. So we will work out that problem in differentiation, and after that we'll get into integration, right? No problem like doing, there won't be any problem, right? This is only one problem I have in differentiation. We'll complete that problem. That problem was in my to-do task, okay, to-do list. So what I'm going to do is let's work out that problem in differentiation. After completing that problem in differentiation, I'll get into the integration. I have some problems, we'll work out into that integration. So as differentiation is, um, differentiate the function differentiate the function with respect to x. So the function is y equal to cos into root x. So this is the function. We need to differentiate this function with respect to x. What does it mean? I need to find the value of dy by dx. So if I find the value of dy by dx, the solution is obtained. So here a little bit of concentration is required. And see, we are having a trigonometric function. So while using trigonometric function, you need to do certain calculations, certain amendments over here and there, so that only you will be able to get the right solution. So we need to use the trigonometric identities also while solving this function, which consists of a trigonometric function, okay, trigonometric term. So let this be equation number 1. Now I am going to find dy by dx. Dy by dx is nothing but cos into root x. See, root x, in your lower classes you would have learned root x is nothing but x to the power half. Okay, I can write root x, or I can also put it like this, x to the power half. Both remains the same. Similarly, if I have 1 by root x, I can put it as 1 divided by x to the power half, because root x value is x to the power half. Or else I can also write it as x to the power minus half. 1 by x to the power half can also be written as x to the power minus half. I am bringing this denominator term to the numerator, provided I am changing the sign in the power. So I will be getting x to the power minus half. This is a basic concept which you would have learnt in your elementary classes, right? Just a small recap of it, because we are going to do that function in this problem. So now what is dy by dx? Dy by dx is nothing but cos x. So this is cos root x. What is dy? Differentiating cos root x with in terms of x. We will be getting cos of root x is nothing but minus sine root x. Okay, so instead of putting like root x, what I'm going to do is I'll put it as x to the power half. I'll put it as sine into x to the power half. Okay, minus sine x to the power half. Now I'm going to differentiate this one. If I differentiate x to the power half, if I differentiate means it will become half into x to the power half minus 1. What is half minus 1? It will be minus half. So it will be minus 1 by 2. It is minus 1 by 2, right? So I am using this d by dx of x power n, d by dx of x power n, which is nothing but n into x to the power n minus 1. This is the differential, generally a general form, d by dx of x power n. If you want to differentiate x power n, this is the result. So based on this, I have arrived into this solution, right? So now what I can do is I can bring this x to the power minus half to the denominator. So it will be like minus sine x to the power half can be written as root x into 1 divided by 2 into x to the power minus half. When it comes to the denominator, it will be x to the power half. X to the power half is nothing but root of x. So now it will be minus sine root x divided by 2 into root x. So this is the solution for this one. If you differentiate y equal to cos root x with respect to x, you will be getting dy by dx, which is nothing but minus sine root x divided by 2 into root x. This is the solution, right? So we will move on to the other problem in integration. We'll move into the integration part now. I have a question like e power x, e to the power x divided by 1 plus e to the power x into 2 plus e to the power x, 2 plus e to the power x into dx. I'm sorry, just 2 plus e to the power x, 2 plus e to the power x. So I need to integrate it. So what I can do is I can assign I equal to integral e to the power x divided by 1 plus e to the power x into 2 plus e to the power x into dx. Now I am bringing the entire term, denominator, numerator, both the terms under the integration symbol, and I am equating it to I. Okay, I, and I'm adding this dx. So now what can be done over here? See, now substitution, integration by substitution process should be carried over here. So what I'm going to do is, let us assume that e power x equal to t, e to the power x equal to t. So when e to the power x equal to t, now I'm going to differentiate this with respect to t. What will happen? E power x into dx, e to the power x into dx equal to dt. I'm going to integrate x with respect to t. So I got is e power x into dx is equal to dt. So now what I can do, I can utilize this expression. Now I equal to integral tends from e power x into dx. What is e power x into dx? E power x into dx is nothing but dt. So that will be dt. I'm substituting it instead of e power x into dx as dt. Now 1 plus e power x is nothing but 1 plus e power x is equal to t. So 1 plus e power x will be 1 plus t. 2 plus e power x is nothing but 2 plus t. So 2 plus t. So I have got a similar expression from the previous one. I have derived something. Now what I'm going to do is, you have another formula, integral of f dash of x divided by f of x will be equal to log of f of x plus c. This formula I'm going to use here. So what does it say? F dash of x. If I differentiate f of x, it will be f dash of x. So the differential on the numerator and the principal value on the denominator, if I integrate, means I'll be getting log of the value that is being placed in the denominator, f of x plus c, which is called as the constant of integration. This is the formula which I'm going to use now. So if I do like this, means, see, what does it mean is, this function's differential should be in the numerator. Similarly, 1 plus t, what is the differential of t? dt. Similarly, 2 plus t means, what is the differential of t? dt. So the principal term is there in the denominator, the differential of this term is placed in the numerator, that is dt. So I can go ahead, very well go ahead with this formula. So if I happen to use this formula, my problem will get reduced to integral. So I should not use integral. I should use, which is equal to log of f of x. Instead of f of x, I am putting it as log of 1 plus t minus log of 2 plus t plus t. Now I am closing with the square bracket and I am adding the constant of integration over here. So what is log of 1 plus t minus log of 2 plus t? This is a logarithmic form. This is in the logarithmic form. So we know a formula log m minus log n. What is log m minus log n? Which is nothing but log of m divided by n. This you would have learnt in your lower classes. Log m minus log n is nothing but log of m divided by n. Similarly, this expression is also here. So log of 1 plus t minus log of 2 plus t is nothing but log of, this is m term, this is n term, n term. Okay, so it is equal to log of m by n, which is 1 plus t divided by 2 plus t plus c. So now what are we supposed to do? We got this value as log of 1 plus t divided by 2 plus t plus c. Don't stop here itself. Now what are we going to do? We need to decode it. Okay, we need to decode it. What is the value of t? T we have assumed it as e power x. So why don't we substitute e power x in terms of t in this expression? Let's get started. Okay, so I'm writing here due to lack of space at the bottom of the board, which is equal to log of 1 plus t can be written as 1 plus e power x, 1 plus e to the power x divided by 2 plus t, which is nothing but 2 plus e to the power x plus c. So this is the final result, which is equal to log of 1 plus e to the power x divided by 2 plus e to the power x plus c. This is the result of this problem, right? Next we'll get into another important part called as the antiderivative, how we need to find the antiderivative. So let's get started with the basic problems. Let's start with a simple problem. So find the antiderivative of cos 2x. You need to find the antiderivative. Find the antiderivative of cos 2x. Cos 2x. So I have this term cos 2x over here. So what I'm going to do, if I want to find the antiderivative of this one, I don't know how to find it. Let it be y equal to cos x something. So this is the derivative. So what will happen if I integrate this portion? So let us assume that integral of cos of 2x into dx. If this is the value, question means what you will do. Integral of cos is sine, which is sine of 2x. This is not a differentiation, this is integration. So what I'm going to do is I'm bringing this 2 over here. Sine 2x divided by 2 is the value which I got which I will get if I integrate cos 2x into dx. So sine 2x divided by 2. So for example, if I happen to put d by dx of sine 2x divided by 2, what will be the result? I need to take this half outside, half 1 by 2 into differentiate sine 2x. If you differentiate sine 2x, it will be differential of sine will be cos 2x. This 2 into 2, right? So 2 gets cancelled. So the resultant value is cos into 2x, which is nothing but our question. We are able to get this question itself. If we differentiate this term sine 2x divided by 2, therefore the antiderivative of cos 2x is nothing but sine 2x divided by 2. This is the value. Now we'll find the antiderivative of another polynomial expression. See, if the expression is 3x squared plus 4 into x cube. 3x squared plus 4 into x cube. We need to find the antiderivative of this expression. So what are we supposed to do? See what thing is, if you get this expression, try to integrate it and get the resultant value. So if I integrate this one, integral of 3x squared plus 4 into x cube into dx. What is the value? Which is nothing but integral of 3 into x squared into dx plus integral of 4 into x cube into dx. So I'm bringing this 3 outside. 3 integral of x squared into dx is nothing but x cube by 3. X cube divided by 3 plus 4 into integral of x cube into dx is nothing but x to the power 4 divided by 4. Okay, so this is the value plus c. So now 3 gets cancelled, 4 gets cancelled. So the resultant value is x cube plus x to the power 4. This is the plus c. This is the expression which we have obtained while we integrate this term, this polynomial term. So what are we supposed to do? We are getting with x cube plus x power 4 plus c. So what I'm going to do is, if I differentiate this d by dx, d by dx, if I integrate d by dx of x cube plus x to the power 4, I'll be getting as x cube. If I differentiate x cube, it will be 3 into x squared, and x power 4 on differentiation will be 4 into x cube. So this is the value. This is the value. This is the question. It's a 3x squared plus 4x cube. We also obtained 3x squared plus 4x cube. How we obtained it? We obtained it by differentiating this term x cube plus x power 4. Therefore, the antiderivative of this expression is nothing but x cube plus x to the power 4. So this is the solution. Let's get into another problem. Find the antiderivative of sine 2x. We need to find the antiderivative of sine 2x. Similarly, like cos 2x, which we did in a previous problem, we should find the antiderivative of sine 2x. So what are we supposed to do? Do the integration process. Integration of sine 2x into dx. So integral of sine 2x into dx is nothing but minus cos 2x divided by 2, right? So now what are we going to do? Let's get this integration result. Let's differentiate this integral result. So if I differentiate d by dx of this term, that is minus cos 2x divided by 2, what will I be getting? I need to take this minus half outside. So minus 1 by 2 into d by dx of cos 2x is nothing but, if I differentiate cos, the value will be minus sine. So I'll be getting minus sine 2x. Sine 2x on differentiation will be, this 2x on differentiation will be 2, right? So 2 gets cancelled. Minus into minus plus. So the value will be sine into 2x. So sine 2x is nothing but the value, the question. We have arrived at the question. How I arrived at the question? By differentiating this value, minus cos 2x by 2. This is the value which was responsible for me to get the question, the value which the question value itself. So the antiderivative of sine 2x is nothing but minus cos 2x divided by 2. So this is the answer, right, for this problem. So now we'll get into another problem, cos 3x. What will happen if I put it as cos 3x? If I put cos 3x instead of sine 2x, Instead of sine 2x, I am putting it as cos 3x. Cos 3x. So what I'm going to do now, integral of cos 3x. What is integral of cos 3x into dx? Integral of cos 3x into dx is nothing but sine 3x divided by 3. Right? So if I differentiate this integral result, d by dx of sine 3x divided by 3, which is nothing but 1 by 3. I am going to take it outside. So differential value of sine 3x is nothing but cos 3x into 3. So 3 gets cancelled. So the resultant value is cos 3x, which is our question, cos 3x. So this is the value which was responsible for getting this answer. So sine 3x by 3, which is nothing but, therefore the cos 3x, the antiderivative of cos 3x is nothing but sine 3x divided by 3. This is the answer solution for this problem. Sine 3x divided by 3. So let's get into the other thing. If the value, it's going to be an exponential form, antiderivative of an exponential, how are we supposed to do? Let's solve one problem which is based on an exponential value. Antiderivative of e to the power 2x. E to the power 2x. So if I integrate this, what will happen? Integral of e to the power 2x into dx. E to the power 2x into dx will be e to the power 2x, e to the power 2x divided by 2 plus c. This is the value. So what I'm going to do is I'm going to take this value and I'm going to differentiate this with respect to x. So d by dx of e to the power 2x divided by 2 will be half. I'm going to take it outside. D by dx of e to the power 2x will be e to the power 2x. This 2x on differentiation will yield 2. Okay, so 2 gets cancelled. So e to the power 2x. This is the question. So how am I able to get this? By differentiating this value. Therefore, the antiderivative of e to the power 2x is nothing but answer is equal to e to the power 2x divided by 2. E to the power 2x divided by 2 is the solution for e power 2x. Right? So we have completed this. Then let's get into the other term. If we get an algebraic term, what are we supposed to do? Find the antiderivative of an algebraic term. So we'll do that problem also. Antiderivative of algebraic problem is if they ask ax plus b whole squared, how are we going to find the antiderivative of this algebraic term? So what I'm going to do, first thing is we need to integrate it. On ax plus b the whole squared, on integration will yield integral of ax plus b whole squared into dx. How we are supposed to do? Integral of this into dx, it looks like integral of x power n into dx, which is nothing but x to the power n plus 1 by n plus 1 plus c. This formula, you need to substitute this formula over here. So how are we going to do it? For that, what we do is, it will be ax plus b divided by ax plus b whole power n plus 1. What is n? N is 2. 2 plus 1 is 3 divided by 3. Okay. This ax, we need to integrate this. We need to integrate ax. Ax on integration, what will happen? Which is equal to 1 divided by a. You got it? So 1 divided by a. So this is the resultant for this one. Ax plus b, 2 plus 1 is 3 divided by n plus 1, that is 2 plus 1, which is 3. And ax on differentiation will be getting, on integration, ax 1 by a. We need to put it over here. So now I'm going to differentiate this d by dx of this term. This term is 1 by a into ax plus b by 3, this whole cube. If I differentiate, how it will be? So what I'm going to do, what are the common terms? I need to bring it outside. It is 1 by a into 1 by 3. 1 by a into 1 by 3 is nothing but 1 divided by 3 into a. We have this term as ax plus b whole cube. Okay, that is dy by dx. Before doing differentiation, we need to do some adjustments over here, some amendments, so that we'll be able to get the required solution. So 1 by 3 into ax plus b whole cube. Now, what I'm going to do is, you can apply this formula x power n into dx, which is nothing but n x power n minus 1. This I can apply in the square bracket. If I apply it, I'll be getting as x power into dx, which is equal to n x power n minus 1. So which is equal to 1 by 3a into nx, 3 into ax plus b. Okay, nx to the power n minus 1. N minus 1, 3 minus 1 is 2. And differential of ax is nothing but into a. That's all. So what are we supposed to do? Here we have 3, here we have a. Here there is 3, here there is a. So 3a, 3a, 3a gets cancelled. So we are left out with ax plus b whole square, which is nothing but our question. So how am I getting this one? I am getting this value when I differentiate this term. Therefore, the antiderivative of ax plus b the whole square is nothing but 1 divided by 3a into ax plus b the whole cube. 1 by 3a into ax plus b the whole cube is nothing but the antiderivative of this algebraic term ax plus b the whole square. You got it? Right. Now we'll do an antiderivative for another trigonometric function. Okay, I'll rub it. They can also ask you a question like this. Find the antiderivative of sine 2x. Sine 2x minus 4 into e to the power 3x. Minus 4 into